to the today's classes. Subject is quantum chemistry. What is hybridization? By Veerabhadraya Demaya. Contact 9663828428. Well, friends, this is Niels Bohr, 1913. Niels Bohr proposed a theory, Bohr's theory of hydrogen ion. Now, Bohr's hydrogen atom is having its own importance in the quantum theory of quantum chemistry particularly. Now, let us discuss about after Bohr's quantum theory of radiations and quantum Bohr's models concerned, Planck's quantum theory and Albert Einstein's theory of mass and energy relation. All these things are having a knowledge over all those things. So let us discuss about the hybridization. In chemistry, orbital hybridization. What is hybridization? That is very important, is the concept of mixing atomic orbitals into new hybrid orbitals with different energy shapes, etc. than the component atomic orbitals, suitable for the pairing of electrons to form chemical bonds in valence bond theory. My dear friends, this is a modern physics and the modern chemistry, which is a quantum physics or a quantum chemistry, which is having a higher or a applied knowledge, applied science. This applied science, let us discuss about the hybridization. The chemical bonding in compounds such as alkynes with the triple bonds is explained by sp hybridization. What is hybridization, my dear friends? Certain chemical bonds, and I would like to divert your attention towards the valence bond theory and about other theories of chemical bonds are concerned. Sometimes unfilled orbitals and off-filled orbitals plays a dominant role in the hybrid formation of the substances, chemical bonding particularly. For example, sp hybridization, the combination of s and p hybrid, that is the s orbital electrons and p orbital electrons, can combine together to form a hybrid orbital, which is sp hybridization. Here, my dear friends, this indicates, this image or a figure indicates about the s and p hybridization. This sp hybridization is having a bond angle between the sp hybridization is 180 degrees. That is, 2s orbital is mixed with only one of the three p orbital. 2s orbital is mixed with only one of the three p orbitals. The px, py, pz, there are the three orbitals, out of which only one of the three p orbitals leads to the formation of sp hybridization. My dear friends, here the carbon is having, this is 1s, 2 electrons are there. This is sp, this is sp, and this is 2p, and this is 2p. All are off-filled electrons. This is 4 electrons which are off-filled in sp and sp, s2p and 2p. So thereby the 1s orbital is fully filled. But in case of the remaining outermost electrons, the valence electrons are the valence orbitals. These are the sp 1 electron, and this is sp 1 electron, 2p 1 electron, and this is 2p 1 electron. These are the 4 unfilled electrons, the unpaired electrons, which are responsible for the tetravalency of carbon. This leads to the sp hybridization in the formation of the compounds such as alkynes with the triple bonds. In chemistry, orbital hybridization is the concept of mixing atomic orbitals into new hybrid orbitals, as I discussed. For example, ethene C2H4, that is ethene, a double bond between the carbons. For this molecule, carbon sp2 hybridizes because 1 pi bond is required for the double bond between the carbons, and only 3 sigma bonds are formed per carbon atom. In sp2 hybridization, the 2s orbital is mixed with only 2 of the 3 available 2 orbitals. For example, here you see this is important formation of chemical bond, that is sp2 hybridization. This, the angle between the 2 bonds is 120 degree. Here the sp2 hybridization, the 2s orbital is mixed with only 2 of the 3 available 2p orbitals. Because of this is the important concept. The 2 pi bond, 1 pi bond is required for the double bond between the carbons, and only 3 sigma bonds are formed per carbon atom. In sp2 hybridization, the 2s orbital is mixed with only 2 of the 3 available 2p orbitals. Well, hybridization describes about the sp3 hybridization. That is, here the atom's point of view for a tetrahedrally coordinated carbon, example methane, the carbon should have 4 orbitals with the correct symmetry to bond to the 4 hydrogen atoms. Carbon's ground state configuration is 1s2, 2s2, 2p2, or more easily read. This is the ground state of carbon atom. Quantum mechanically, the lowest energy is obtained if the 4 bonds are equivalent, which requires that they are formed from equivalent orbitals on the carbon. A set of 4 equivalent orbitals can be obtained that are linear combinations of the valence shell. The core orbitals are almost never involved in bonding s and p wave functions, which are the 4 sp3 hybrids. In CH4, 4 sp3 hybrid orbitals are overlapped by hydrogen 1s orbital, yielding 4 sigma bonds, that is 4 single covalent bonds of equal length and strength. In methane, 4 sp3 hybrid orbitals are overlapped by hydrogen 1s orbitals, yielding 4 sigma bonds, that is 4 single covalent bonds of equal length and strength. This is how the quantum mechanical concept explains about the formation of methane, that is sp3 hybrid orbitals. So my dear friends, we have discussed sp hybridization, sp2 hybridization, and sp3 hybridization of this quantum mechanical concepts. Now, review of the quantum numbers. I would like to divert your attention towards the orbitals, especially how the s is equal to 0, p is equal to 1, and d is equal to 2, and f is equal to 3. These are the subatomic suborbitals, principal orbitals. After that, they are further divided into spdf orbitals because of the unfilled electrons in the distribution of electrons in the atomic structure. Electronic configuration and the periodic trends. Follow the yellow brick road. Start here from this 1s2, then 2s2, then 2pcx, 3s2, 3pcx, 4s2, 3d10, 4pcx, and 5s2, 4d10, 5p6, 6x2, and 4f14, 5d10, 6p6, and 7s2, and then 5f14 and 6d10 and 7p6. Like this, it will continue. The atomic size increases from 1s2 to 7p6 in the periodic table. Let us discuss about the Ahbab principle and other electronic configuration and periodic trends in the forthcoming classes. Thank you for listening, my dear friends. See you again in the next class. Like, share, subscribe. Thank you.